Unit testing is a process in which the smallest testable parts of an application, called units, are individually and independently scrutinized to ensure that the code operates as it is intended to. There are two key phrases in that definition that one should be aware of. The first is that unit testing is done on the smallest testable parts. Now, what does that mean exactly? Well, it means that the code needs to be complex enough that it is testable, but at the same time as small as possible. So this could apply to functions, interfaces, classes, or procedures in software code. The other key phrase to keep in mind is that the unit needs to be individually and independently scrutinized. In other words, when you're testing the unit, you need to test only that unit. So if testing of a unit spills over into the testing of another unit, then it's a problem. This is best demonstrated with an example. So if let's say we have a class, and that class makes a database call. Then to ensure that that class is working properly, it depends on the database to work correctly as well because it makes a call to that database. Um, and so in this case, testing the class individually might require some extra handling. We might need to, for instance, create a quote unquote mock object that mimics how the database works in the specific scenario, and then test the unit with the mock object. However, learning how to handle complex cases in unit testing is beyond the scope of this presentation. So for this, just keep in mind the two phrases that we have discussed, that one performs unit testing on the smallest testable parts of an application and that they're individually scrutinized. So let's look at an example of a unit test. Here we have a calculator class with a few functions to add some numbers together. We want to ensure that the calculator functions properly. In this case, that means that it can correctly add numbers together. On the right-hand side, we can see an example of a unit test. This test tests the calculator class to ensure that when the user enters a 2, a plus sign, another 2, and then an equal sign, the calculator displays 4. The function is organized in a common format known as arrange, act, and then assert. This means that you first set up the test by initializing a couple values, the expected output and the actual calculator class. Then you have the code to act on the unit. This means calling the necessary functions in the calculator class to get the expected output. Finally, we have the assert section, which checks to ensure that the expected result matches the actual result. In this case, that 2 plus 2 actually displayed 4. While this is a very simple scenario, the software developer may have several different functions to test all kinds of user input to the calculator class. Usually, developers will create a list of these simple unit tests into one test suite, which can automatically be run before a new release of the software to ensure that each use case is functioning properly and that there are no unintended side effects of new code that may have been written.
Hi, my name is Tyler Willis, and it is my job to talk about the advantages and disadvantages of unit testing as my section of the presentation. So I'm going to start on the first slide of advantages. One advantage of unit testing is that you can discover problems early. Unit testing helps isolate an error to one specific section of code. And these isolated units force the author to be more cognizant of inputs, outputs, and possible errors before the code is written, which is just helpful because it's a lot easier to know what could go wrong when you know what each unit is supposed to do and what their expected inputs and outputs are. Often unit tests are made before the code itself is written, making problems easy to detect early on. Another advantage is that you have increased confidence when changing code. Basically, it's much easier to know if the change that you made actually worked. If you only change one unit and then you can test it, and if it worked, then you know that the problem came from that unit. Simplified integration testing, testing the units individually first, makes integration testing go much smoother. Okay, so moving on to the second page of advantages, units must be modular. Unit testing forces code to be at least somewhat modular. It makes the code much easier to reuse and sort of reorganize. And it's just a general good coding practice for any sort of programming. Another advantage is that there's better documentation, because this system forces the author to keep track of all of the units and whether or not they work and what they do and things like that, because it becomes a mess if you don't keep track of it. And documentation is important, so this system is good for that. Debugging is easy. When something goes wrong, only the most recent changes need to be tested. Without unit testing, sometimes a problem will arise, and it can come from something that you changed a long time ago, and there's really no way of knowing. So unit testing really helps with that. Problems can be easily isolated to one specific unit. Okay, moving on to the disadvantages slide. Unit interaction is hard to test, so less focus is placed on the overall program functioning correctly. It's nearly impossible to evaluate every execution path. Units may work individually but create problems when we're working together, so if all of your units work, you might think that the program will work, but maybe they don't interact with each other correctly, so that can create some problems. Some problems can't be easily tested, like non-deterministic problems with non-quantitative outputs, and code dealing with random numbers, and things like that. They can be hard to actually know if you're getting the right output because they're hard to test. And unit testing creates many more lines of code. Each line of code can potentially need 3 to 5 lines of test code, which obviously makes the program much longer, and it can affect the performance. And so those are the advantages and disadvantages.
Hi, my name is Matthew Brown, and today I'm going to talk to you about when you should use unit testing. Well, quite frankly, my answer to that question is almost always. Anytime you work on a project that has thousands of lines of code, or potentially even more, you're going to want to use unit testing to increase the quality of your project, increase the quality or the flexibility of your code, and also decrease the amount of time it takes to debug your code when you come across a problem. In the end, everyone's going to be a lot happier when you use unit testing for your project. Now I'd like to talk to you about a leading design pattern known as test-driven development. Test-driven development ensures that developers write quality code by requiring them to write unit tests before they write their code. For instance, if they want to write a function that defines some kind of behavior, they must first write a unit test that can test that functionality, and also they're not allowed to write another function until the unit test passes. And what this does is makes sure that their code is testable while also being very decoupled from other code. If a project has well-written unit tests, with unit tests that cover most of the code inside of the project, then the project is very flexible. Now, the reason why this is important is because oftentimes in software development, you have a project that has requirements that change, or for one reason or another, code has to change. Now, if it's well tested, if there's unit tests for it and it's well tested, then if you have to change the code, then after you make the change, you'll know whether or not the code is valid very quickly, because you can simply run your unit tests and see if they all pass. If they all pass, then your code is valid. If not, well, you have a problem, and now you know because you wrote unit tests. Unit tests also makes your project a lot easier to debug, and this is important because if your project's easier to debug, then costs go down. Unit tests help you to pinpoint exactly where your bugs are in your project. If you have all your tests and you run them and some of them fail, well, you can be pretty sure that you know where some bugs are.